Good morning, everyone. It's a pleasure to be here today to talk about industrial waterborne preservative systems for poles. My name is Tim Carey and I'm with LSI Wood Protection. Before we get started, I'd like to go over a few items to assist in making today's event simple. This is an example of the attendee interface right in front of you on the screen. You should see something similar on your desktop in the upper right-hand corner. The audio defaults to your computer speaker system. If you would prefer to join over the phone, just select telephone and in the audio pane, and the dial-in information will be displayed. Please feel free to write in questions during the talk and we will address them as we go along. We will also address any additional questions at the end of the talk. So why me? I've spent 45 years working with treated wood poles, over 25 of them inspecting them at pole plants and also in line and providing remedial treatments and reinforcements. In the process, I've become involved with the organizations such as ANSI, ACO5, AWPA's Committee T4 on the treatment of wood poles, and CGRADE, the global utility organization, and their wood pole working group. While I work with a waterborne preservative manufacturing company now, most of my early years were spent working with creosote and penta-treated wood poles. Most of what I hope to get out of this talk today are questions, either now or when you get back and talk with your folks. You're having to make some important decisions in the near future. If I can help, I will be glad to. Before we get into the main topics, let's remember that there are no perfect materials. There's always going to have to be a level of maintenance and guidance as to the proper use of any products on an electrical system. As you can see, all these products have some kind of an issue at some time. The other thing to remember is when it comes to resiliency and ease of replacement, wood poles, after a catastrophic event, nothing beats a wood pole. Your suppliers maintain and can generate some pretty amazing amounts of poles in your times of need. As you can see from these examples from Katrina and Sandy, you're looking at over 92,000 wood poles within 4 weeks for Katrina and roughly about the same amount of 65,100 poles in the same amount of time for Sandy. So these are just examples of some of the things to be aware of. I'm going to talk today about the two main industrial wood preservatives, ACCA, which you may not be familiar with, CCA, which you probably have heard about, and some of the things about them, some of their characteristics and different things to know. One of the things that's really good about these is that their solvent is water, unlike some products where you have to deal with diesel fuel. There's a single retention for either product as far as all pole hazard exposures. They're easy to analyze and they're easy to verify for penetration. And because of their reliability, that gives you an additional feeling of safety. And they work in the most severe environments, including marine applications. And you can reuse and reset poles without remedial treatment. Some of the characteristics are they're not volatile, they're not oily, they have a paintable surface. The preservatives are fixed in the wood, which means it's very difficult to move them out, and they don't have a conductivity issue. And the only thing that you may see is they swell a little bit when they're treated because of the water, but then it dissipates very quickly after treatment. So a little bit about history. Most people think that CCA in particular has only been around since the 70s because that's when it became popular for residential use. But actually, it's been around since the 30s. ACCA has been around even longer. It was developed in the 1920s on the West Coast. And it's basically been used for treating Western wood species, which are very difficult to treat versus the pines that we have in the East. But it does have over 90 years of service. And it's, once again, easy to do the retention and penetration. And they both have very long lifespans based on studies done by the Forest Products Laboratories for the U.S. Department of Agriculture. Enhancements, while ET is a proprietary emulsion that we have, it can be used with ACCA. However, there are no currently commercial plants treating with it. and so it can improve climbability. However, what we have seen commercially is borate inclusion, which improves both preservative protection of Western species and their fire retardancy. For CCA itself, we do have the ET and a number of plants that do that, and it does improve climbability and performance. And you'll see more about that as we go through the presentation. This just kind of gives you an idea of what happens when you blend borates in with ACZA. On the left is what you would expect with a typical ACZA treatment of Douglas fir. It doesn't go very deep because of how hard it is to treat the wood. However, boron continues to move through the wood and goes all the way through the core. So you can see from this that you've got a fully treated piece of wood, which you don't normally expect on Douglas fir. One of the things I always think it's important to make sure people understand is what a pole brand is, since that's on every pole. And as you can see, first you have the producer at top, the location, which is the city, the preservative, which in this case is CCA, and you'll notice that it doesn't say CCA, it says SK. When CCA was approved in AWPA, it was the K version of a salt treatment. So that's why it became in that part, because in the early days they did it by the alphabetical order. Retention is 0.60, and that's what it is for poles, both CCA and ACZA. In this case, there's an additive in there. This is that should appear on the brand, in this case ET. Here's your month and year of production. And here's your species, southern pine. And the class and height will also appear. The other thing is, if you're using a quality control program or an independent inspection agency, their designation should appear on the brand as well. In this case, WQC is the quality control program used by rural electric cooperatives. We're going to talk a little bit strictly about ACZA now. The basic formulation is 2 parts copper oxide, 1 part zinc oxide, and 1 part arsenic pentoxide. It's diluted at the treater's plant. There's some aqua ammonia added, and it is also heated for treating, and it's the only waterborne preservative that actually incorporates heat. It was originally, as we talked about earlier, developed in the 20s. The first commercial plant was built in 1935. J.H. Baxter was the owner after the 30s, and they reformulated it into ACZA. It is approved by both the EPA and PMRA, which are the organizations in the government that approve pesticides, and it has AWPA and CSA acceptance for industrial products. And Arch Wood Protection, our predecessor, purchased ACZA from J.H. Baxter in 2007. Some of the things that are pretty nice about ACZA is that carpenter ants and carpenter bees have a high mortality rate. It's also very good against Formosan termites. And in a study done by a utility in Virginia on transmission poles, they found that it reduced woodpecker attack over a 10-year study. It also provides some fire retardancy and reduces flame spread. And it does not affect conductivity. And one of the things that people ask about is corrosion, and I'll show you in a little bit some testing that's been done to verify that it does not affect the corrosion. It does not affect corrosion on hardware. And because it is heated, it allows you to have steam conditioning as well as a heated treating solution and aqua ammonia, which helps provide sterilization in the treating process. In fact, it treats so well in difficult and refractory species that not only ACZA is used for Douglas fir as well as hardwoods for ties. And here's some of the typical uses: poles, piles, posts, different kinds of stuff and saltwater, bridge timbers. And one of the advantages is that you can do post-laminated timbers with ACZA. It's the only waterborne that can be done with. All the other waterbornes, the individual pieces have to be treated first and then laminated. Here's just some pictures of some of the uses of ACZA. One of the recent studies that was done was by Oregon State University over in Australia. They looked at some 22-year-old Douglas fir ACZA treated bridges. And the interesting thing about this stuff is all 2x12s on edge. And the climate exposure, if you look down there at the bottom, you'll see it's a tropical exposure around 75 to 88 degrees, but it's in an area that gets 11.5 feet of rain, which is the equivalent of 68 years of rain exposure in Oregon. This is what the test bridge looks like on top, and then the one on the bottom is an actual bridge that's in use. And the results were that the bridges did very well. Even after 20-something years, they found no decay in any of the boards, which was pretty amazing with that much water. And probably the biggest thing is that the results illustrate that the benefits of prefabrication, in other words, doing all your framing and drilling as much as possible prior to treatment, and then making sure that the material is treated properly so that it will survive. And this just gives you an idea of how it's done in stake tests. The AWPA poll requirements we talked about earlier is 0.60. On 0.25 retention stakes, which is 42% of that 0.6, they've had no failures after 30 years. And then here's what ACCA Polls look like. They have the through boring pattern on them so that it helps improve penetration. And that's done down near the ground line area. And that's done with any preservative that's used on Western species. Here on the left, you'll see the ACCA Douglas Fir poles with the ET Brown treatment, and on the right, just regular ACCA Douglas Fir poles. As part of this is in our climbing facility there in Conley, Georgia. And in 2013, we had them climbed. And you can kind of see the guys going up, because what we found is that linemen like to know how does it actually climb, and the best way we could figure out to do it was to bring poles in, set them up, and let guys climb them every so often. So you can get a better look on the right hand side on the bottom of an ACCA ET Brown pole, and that's what they look like. And this is the results after the 1-year climbing trial. You can see that Douglas Fir alone, this is on a 1 to 10 scale, is better than average. The Douglas Fir with the ET Brown was very close to what the Southern Pine ET Brown was. So it does show that it did definitely improve the climbability of the ACCA treated poles. And here we go into the corrosion study we talked about earlier. We had bolts pulled out of poles after 38 years of exposure, and had them taken to a local independent inspection lab, and they took them and broke them to see how they would do. And you can see it did not affect the strength of the bolts, even after 38 years of exposure. And just to kind of give you an idea, the Class B fire retardancy is what ACCA carries based on this retention. And on top, that's what the Class B is. So even at 0.35, it gives you that level, and we're at 0.6, double that. So those are some things we've looked at and see that should help us improve over time, and we'll be doing more testing in the future. We also did some char studies and comparisons of ACCA alone and ACCA plus borates. And as you can see, the borates further improve the fire retardancy and char resistance of wood products. All right, so now you've been introduced to ACCA, let's go back and talk a little bit about CCA. As you may know, CCA is chromated copper arsenate. It also comes in as a concentrate and diluted with water, and it's under the AWPA P23 standard. And its first use actually was in poles. And the original poles were put in the 1940s. Bell put in 225,000 of them from Florida to Canada. And after 50 years, they could not find any failures due to biological degradation. So that was pretty impressive for those. And that's why they continue to be used for wood poles today. Here's some of the features. These are some of the ones we've already seen. As we talked about earlier, it fixes in the wood. You don't get much migration. You don't have to worry about ground line surface treatments for remedial treatment side of things, and you don't have to rotate them in storage because it doesn't move. This is actually a charge of CCA ET clear poles when they came out of a cylinder. So you can see what they look like. They're fairly clean. You can see a little bit of the ET emulsion on some of the surfaces, but you don't see any dripping underneath the poles there at all. And here's some of the state studies that were done on CCA. These were actually treated at the 0.60, which is the wood pole retention. And after 40 years, there were no failures. And sometimes people ask questions about how flexible are CCA poles rigid. Well, this is a home that was built down on Galveston, that was in an area that was hit by Hurricane Ike. And the CCA treated piling withstood the wind and the storm of a hurricane and continued to stand. And as you can see, it's the only thing in sight. The other thing people get concerned about is there is the arsenic concern. And so we actually hired Gradient to come in and do some independent studies to determine what kind of exposure can we expect for either individuals coming in contact or linemen working on them. And what we found out was that the exposure either on the poles or in the adjacent soils was 14 times less than the intake of naturally occurring inorganic arsenic in food or tap water. So we've looked at all kinds of studies to see that. We have these studies online. You can go to our website, Womanized Wood, gradientpole.html gives you the abstract, or if you want the full report, which is 100 and something pages or so, you can get that on there as well. So it's good information to be able to make sure people feel comfortable that, yes, this is a safe product to use. Now we'll talk a little bit about the ET emulsion systems. They were first introduced in 1988 after a lot of years of trials of trying to find out what can we do to make CCA poles easier to climb, because we realized there was concern by linemen about this. And so rather than trying to say, no, there's not, how can we address it? So we looked at a number of different formulations and finally came up with the emulsion treatment, which is a refined hydrocarbon oil emulsion. And we did it initially we did it as a single treatment with CCA. But then we found out that that was too expensive and too hard to control and moved to a second step treatment where we actually control it to the outer inch of the pole surface, which is where the gaps will be in the pole. So some of the other things that we found that it has done over time is that it reduces checking. It helps obviously maintain climbability over 30 years. And we found that it provides some fire protection as well. And we have reports on that done in Australia. The newer version of ET is ET Brown. We introduced that in 2008. And the posts that we originally did are still around, and they're still brown, although faded, as you would expect, being in Georgia. It uses the same oil as we use in the clear, but it has a pigment-based system that's added to it. So one of the things you can think about is that we have some utilities that actually only use the ET on poles of a size they climb. In other words, they just buy straight CCA poles for areas where they know they're going to be using buckets, not have to worry about it. But that's totally a utility decision of how you want to go about doing it.
Excuse me, Tim, we have a question from the audience.
Yes.
Did you say that CCA poles do not require ground line treatment over the life of the pole?
That is correct, because it doesn't leave the wood. What you may find over time is that if something gets behind the surface, you may need internal treatment, but you will not need a surface treatment. And we have a 50-year warranty that covers that without having to do it. Now, that being said, all poles should still be inspected. In other words, it should be looked at for things like loose bolts, loose guy wire, things that may have happened, twists. So it's not that you shouldn't inspect them, but you should never have to ground line treat them on the surface. Okay.
Thank you.
Sure. All right, and we've had these poles in our test site now in Conley, Georgia for actually over 30 years now. Our last climb was at 30 years. So we could evaluate them. And we have Penta Polls in there, we have CCA Polls, and we had several versions of ET Emulsion as we were trying to decide what was the level that gave us the best climbability for the cost. And we came up with that. And so and this is a comparison of those. And as you can see, the ET definitely improves climbability over straight CCA. And we feel that's really good, because when people go up to an ET clear pole, they see green. And as most of you know, when the lineman sees green, the first thought in their mind is hard. Well, if he starts to climb that pole and it's not hard, it's a very pleasant surprise. Obviously, it comes in very close and compares favorably with oil-borne Penta in this particular case. And this is what ET Brown looks like if you're curious about that. The top one is an actual truckload of ET Brown, and the bottom one is 4 ET Brown poles on top of some Penta poles that were being shipped to a utility for evaluation. So you can kind of see that if you've been using an oil-borne and you're concerned about appearance, this is one way to address that. So anyway, just something else to think about as we continue to look at how can we make things better for the end users. And that's it. It's important. If you have questions, ask them. If you need to, you can, obviously you've got my email there, you've got my cell phone number, you can text me, you can email me questions. We have literature if you need that. All you got to do is tell me what kinds of things you're looking for. Would be glad to supply it. And other than that, unless you guys have more questions, that's kind of where we are. We didn't want to take up too much time for anybody, but we wanted to at least give you some things to think about as you have to make these decisions going forward. But thank you.
Tim, we have a few questions.
Sure.
Does ET help with woodpeckers?
We have not seen that. I cannot say yes or no. I have not seen any data or information on that. The one way that it might is the fact that it reduces checking, which may help keep bugs from going inside, because woodpeckers are listening or pecking on it to look for sound. So, but I don't know that. There is no evidence of it one way or the other.
Okay, thank you. Next question. Do we need special gaffs to climb waterborne poles?
No, we've done in our climbing studies, all the guys came in, if they were from oil-borne utilities, they climbed the CCA poles with their oil-borne gaffs. And the only thing we have found is that they need to maintain them to the manufacturer's recommended condition. And if they keep them to that, then they should not have any issues.
Okay, thank you. Next question. Are the characteristics you mentioned for CCA waterborne also apply to the oil-borne treatments, for example, cedar poles?
Yeah, it should. I mean, we do. Cedar poles are treated with CCA, and we don't see any much of a difference. For one thing, cedar is such a soft wood to begin with, so we don't see CCA causing any kind of issues with that.
Thank you.
Uh-huh.
Why isn't ACZA available in the East?
It was developed on the West Coast, and that's where it's been done well. And CCA was obviously first used in the East, and it's been very popular because it treats the pine so well. If you see ACZA in the East, it's typically on transmission lines that came, Douglas Fir or Western Red Cedar, that were brought from the West to the East. There was a treater at one time in Minnesota, and that was as far east as we ever had, and they treated a fair amount of pine poles and did very well.
Okay, thank you. Next question. How do these waterborne preservative treatments actually affect ground line inspection and treatment?
Well, as the question was asked earlier, the one thing that they do is that because they're fixed in the wood, they don't leach, they don't leave the pole like the oil-bornes do. You don't have to worry about applying a ground line paste or wraps. The only problem you'll ever have will be if there's, for some reason, a check that opens up into untreated wood inside. And in that case, you may need and internal treatment, but there should not have to worry about doing any kind of surface treatments other than, like I said earlier, you definitely want to inspect those poles and look at them to make sure that the poles are still doing what they're supposed to do, as well as the equipment on that pole is doing what it's supposed to.
Okay, thank you. Next question. How would you characterize the key advantages and disadvantages of CCA-ET compared to DCOI?
Wow. I guess the biggest difference is that CCA has been around a lot longer than DCOI, and we really don't know how it's going to perform. We're still waiting to see. It may be just as good as Penta. We just don't know yet. But CCA, we know, has a long history. It has a 50-year warranty that doesn't require ground line treatment, which some of the other warranties sometimes require. It's just a very long, a very substantial preservative system for protecting wood, because it can actually be, like I said earlier, can be used in marine environments on piling placed in the ocean. So if it can hold up there, it can hold up to just about anything anywhere.
Okay, thank you. Next question. How does ET affect the cost of CCA polls?
You'll obviously see it's going to cost more, obviously, because it's an additive and it's a second step. It's in the past, it's always been very comparable to oil-borne treatments, or at least not much more, because there's not a lot of oil in there, and the oil is a refined machine type oil, so the pricing of that doesn't go up and down as much as, say, the diesel fuel that's used in the oil-borne preservatives. So you'll see it will be more, but it won't be significantly more. But it should be definitely very favorably competitive to the oil-bornes.
Okay, thank you. Last question that we have. Are ET Clear and ET Brown readily available?
ET Clear is very available, and ET Brown is becoming more and more available. We've probably got a dozen plants treating with ET Clear and a half a dozen treating with ET Brown.
Okay, thank you. Are there any more questions? Anyone can type a question if they'd like to do so now. I don't see anything coming in, Tim. Thank you.
Okay, thank you. I hope everybody has a good day.